Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Rocket Monday, we're going to talk about how the heck space programs are funded. So let's dive deep into it. So basically you have to understand this puppy is expensive. Now why it is so expensive? Well, inherently because of the environment, meaning when you have to make a boat that handles rivers is cheap. When you have to make a boat that can handle ocean, it's very expensive. Because again, corrosive environment. Same happens in space. It's brutal environment. It's one of the most hostile environment. Like that puppy has temperature extremes that make like there is no place on Earth that has that kind of extreme. You can have places on Earth that gets very cold. You can have places on Earth that gets very hot. But space does both. As in, it can go from minus 150 degrees Celsius to plus 150 degrees Celsius, as in a zone of 300 degrees Celsius in basically low Earth orbit. When you are going, like, assume you have a black ball and it goes to the size where the sun is shining, it cooks to 150 degrees Celsius, goes to the side, and because it's a black body, it radiates everything away, minus 150 degrees Celsius. And here's the funny thing, it happens many times per day continuously. It's a miracle that ISS had lasted this long to survive that sort of onslaught of thermal expansion and contraction for that long. It's brutal because again, you do not have any environment, as in like atmosphere, to regulate it or to equilibrate it. Earth is also getting exposed to the same environment because we have basically a blanket of atmosphere that is stabilizing everything. And space has radiation. Now here's the interesting thing, if you know anything about radiation, radiation does not mean anything. You have to specify alpha, beta, gamma, and neutron. Space has everything. Space has radiation, yes. What radiation? Yes. Basically it has alpha, beta, gamma, heavy ions, and proton based radiation, and neutron doses. Basically if a cosmic ray hits some parts of your ship hull, it will emit neutron. Yeah, it's bad. Let's just be very clear about it. Electronically it's bad. Living creature, it's bad. Like it's very hostile out there. Like it's complex how the heck we figured out how to put humans there and keep them safe for longer. Again, let that be clear, it does not mean when you go outside of a Van Allen radiation belt you get ship deleted. It simply means your life expectancy goes down and you really do not want to do it for long doses. So that also makes everything far more brutal. And you have limited size and environment because again, this temperature range, this sort of radiation environment, that's like a submarine is like, bro, I can do this in sleep, but here's the submarine is heavy. When you're talking about something that has to go on top of a rocket, not only it has limitation in size, but it also has limitation in volume, basically how dense it can be. So that creates an issue. The moment you have all of that, it's very hard to do. On top of that, you add the fact that it has to survive high vibration launch environment. Yeah, and most common public do not have understanding how loud rockets are unless you are lucky enough to physically be there when people are launching Starship. You must have seen, like, there are videos now, people like very far off and their whole house buildings are like the glass are shaking, and even though the rocket is very far away, imagine what is happening inside the rocket. It's brutal. So fundamentally, if you're putting a payload, it has to survive space environment, and it has to survive launch environment, and it has to be a lightweight and limited size, so to the volume, so to say. Yeah, all of this makes it bonkersly expensive. It's not that it can't be done, it's just it can never be done cheaply, inherently speaking. So we started like government. Well, why did government went into it? Because inherently this is what we call very high risk, because it's not known, technology is unknown, you have no idea, and reward is like very low, like maybe some reward. So how the heck funding started? Well, funding did not start in space, it started in war. V2, the first proper ICBM, rudimentary one, this puppy started simply because it was a boom boom device. They wanted to send it and go boom boom on it. So that's how it started. Why did NASA was built? Because of Cold War. How the heck NASA got the money? Because of Cold War. Let that be very clear. The money always came from war. Like many times people will say, oh, if NASA could land on moon in 1969, why can't they do it now? Well, this is the reason. That was a war funding. Like when you have war funding, you dump bonkers amount of money. Right now, I think, if I'm not mistaken, Russia is dumping more than 50% of its total budget into basically boom boom events. You never do that in peacetime. Like at peacetime, 20% is also too high. And heck, European Union is like, Trump has to fight, like, bro, at least 5%. Come on, bro. So this is 4% of national budget was allocated to NASA during Cold War. And how much is allocated now? What is the average? 0.4%. So let them figure that once the Cold War ended, once they figured out that USSR is not going anywhere, realistically speaking, and that turned out to be true, all the budget was like basically budget was like, okay, we achieved what we wanted to achieve. People lost interest, and then it's like, okay, let's keep it at around 0.9%, 0.9%. 1999 happens, and it's like, yeah, Soviet Union got kaput, sui 0.4. So let them very clear. That's how funding happens. It's from war point, not explorational. Those are basically what you call side tangent benefit. And we have a lot of civilian use too. Once we figured out how to boom each other, then like, hey, we can do useful things. We can make right now it's so important that it was classified as critical technology for national safety and security. So flat out, most nations spend some percentage of the budget. Now again, that could be different based on the severity, importance, how far ahead or how back they are. But most countries are like, be it Canada, be it NASA, be it ISRO, be it CNSA, be it ESA, be it Roscosmos, generally, or JAXA, almost all governments give some amount of money, because not only it's a very important war driver, but it's also very useful in civilian applications also, from weather prediction to all other jazz. So that's how it started. That's how the ball got rolling, war driver, and 4% of the budget. So how do we actually build things? Well, the first topology that is utilized is partnership topology, meaning government has two core things. It has money and it has authority, meaning it does not have to ask anyone. So money and authority is there. So they build organization, and the core aspect of this organization is governance and guidance. Basically, how the heck you're supposed to do something so you do not start a world war event, and guidance like this. These are the rules and regulations you have to follow. And they generally do not have the know-how, meaning you can't expect government to know how to build Saturn V. So that organization will end up designing it. Okay, they design Saturn V, but here's the Saturn V at that point would be very rough ideas. Like, we need something like this. So contracts will go out, and a lot of people will come together and come up with a design. And they will end up contracting, as in F1 engine was contracted to Rocketdyne. And then you have lunar rover vehicle was contracted to Boeing. Then you have command and service module contracted to North American, and then you have third stage contracted to McDonnell Douglas. So that's how it always works. Even right now, if you go into NASA, it's like, okay, NASA is building SLS. No, NASA is not. Like, NASA is designing it. SLS is being built by Boeing. So, and other partners also, but you get the point. It's always like that. And NASA comes up with a design, and they go out with money. It's like, can you guys build this for us? And again, it's true in every place, be it China, be it Japan. It's true in every place where you do that. And question becomes, why burn so much money? Well, country gets massive technology boost. Like, one the other, oh, we have so many problems here on Earth, why are you spending money in space? Well, this is Saturn V. Nobody is putting a brick load of money on the Saturn V and throwing it in space. Where the money is going? Money is going into all these contractors. Where the money is going inside that contractor is the employees who are getting paid, is the miners who are mining the minerals, material, smelting, all of that jazz. So money is spent on national economy, and it gives you technological boost as an added bonus. And this project, like basically Saturn V, printed money so much that it's like, bro, this is the golden child. Like, if you ever have a time machine and go and ship deleted Apollo project, America will not be powerful. Like, flat out, it will not be even half as powerful as it is right now without this. Like, so many technologies started to come out because of this successful project. It's like, damn. So that's how partnership works. But again, it also has backfires. This happened. Space shuttle. Now, why the heck space shuttle had such a weird design? Every government agency wanted, like, I wanted this. National Recognition Office, I want this. Navy is like, I would love this. Air Force is like, I would love this. It's like, CIA is like, hey, what about this? It's like, bro, you can't have that. Like, you just can't put everything in one basket. But they tried to, and this kaput happened. So this is how right now most of the country works, excluding NASA. NASA is like, this is the last phase of NASA where they are in this phase. So now we come to private players. Now, recent privatization of space actually allowed this to happen, where it's like new profit generating ventures are coming about. What does that mean? That simply means you can right now be a space company that does deal in space, and you can actually make money, and government does not have to be included. Of course, as a regulatory body and all that jazz, that's a different thing. But you do not have to basically be contracted or funded by government. That is possible. Basically, right now, the biggest thing you can do in space is making constellation. The biggest constellation is not a government constellation. Like back in the days, we used to have spy satellite constellation, communication satellite constellation, GPS constellations. Those sort of things were very expensive. The government used to put bonkers amount of money into it. However, right now the biggest constellation is Starlink. Starlink is a private entity. Then why the heck a private entity is putting money? Well, because they can make money. So company can make money from selling you satellite internet. People are going bonkers about it. It's like shut up, take money kind of money maker stuff. Then you have TV broadcasting. This was like from 90s. Satellite TV was making money like long before everybody thinks, oh, space is cool now. It's like, nah, that was the first privatization where it's like, hey, geostationary satellite, not all military satellites are there. Like geostationary has a fixed slot, so to say. Most of the slots are not filled by military systems. So TV broadcasting, they're going to Earth observation now. Again, that is a very recent thing where you have a small CubeSat that is like literally scanning the whole Earth. Now, question is there a money in that? Yes. First, because of the, again, regulation part of it, governments get first access, like the first dips, like CIA, FBI, and all of that, they will get first dips. So if a satellite is going over a place, they get the first dips. And after they have security cleared it, then it goes to the public domain. Like generally, I think 24 hours or 48 hours, depending on the design. And once you do that, there are a lot of people who love that data. First, insurance companies, they're like, shut up, take money. Like how this event happened. If you have like overlapping data on big things like marine assets, shut up, take money. Wildfires, things of that nature. Like there's so much invaluable data that's like companies are like, shut up, take money. And you have agriculture. Agriculture is like, because again, you can like, okay, let me figure out how the state is dealing with this agricultural situation. Good luck. But if you have a satellite, it's like, okay, let me, like if you have satellite going over that area every week even, which is not very high density, but you can overlay a week, that means gives you around what, 50 snapshots over a year. You can figure out way more data than you could ever actually do by going there and collecting it. Because again, you have to have a lot of people go to there. And again, USA is big. So right now, there are actual ways of making money privately where all you have to deal with government is just bureaucracy. Like, and the closest thing that we have that could start to print some serious money is this puppy. Basically, satellite to cell. Can we do that? Have normal phone, 5G mobile phone talk to satellite? Yes, physics is there, it's been done, it's proven. So why don't we have the service? Well, bureaucracy. Right now, the biggest issue is how the heck you have a licensing of all the bandwidth that is involved, the radio frequency slices. That has to go through FAA and all that jazz. And because it's supposed to be an international thing, lot of hassle is there, like a lot. It's the technology is there. Let that be very clear. Right now, there are more than enough companies that are like, bro, we can go today. Like, give us license today. Tomorrow, everybody are like, hey, my 5G phone is now satellite phone. It can be done. It's just that we do not have. And I'm not talking about Starlink. Starlink has what you call conjigured solution where they're like forcing the radio to work that way. This puppy was designed to deal with that. So we have a lot of options where a private company get into space and make money in space doing space stuff. And these are what is already happening. What could happen in the future, that's like a completely different domain. This is what we have right now going printing money. So what can we expect in the future? Now, this is the part where you have to understand government is good for governance and guidance, duh, but it's really not good at making technology. Meaning, if you ask government, dear government, can you make me a telescope for $500 million, as in like $500 million? The government is like, I got you, fam, I'm gonna make it. And then you're like, okay, what happened? Yeah, you have to pay $10 billion and 10 years behind schedule. Tell me which telescope I'm talking about. So that happens. And again, let that be very clear. That will always happen. It will happen in ISRO. It will happen in NASA. It will happen with ESA. It will happen in JAXA. It will happen with everything. ESA's scenario is even so tragic even there. Like they know that there is no point of Ariane 6, like, but they have to make it. They call it tough pill to swallow. They are calling it. I'm not saying it. They're calling it. It's like, yeah, it's a tough pill to swallow. It's like, why? Why the heck government of all countries always end up with that? Well, because there is no competition or consequences. Meaning, if a private company has system and they are not performing, other private player should delete that one. So they have to perform. There is actual competition, and failing has actual consequences. I genuinely do not think there are any private options unless you have this sort of government contract where you can be like, oh yeah, we are our budget by how much? $10 billion. It's like, nah. So, and again, what happens when you have that sort of organization? You have delays. That's why all government contracts, almost everywhere on the planet, has that issue. Delay, cost overrun, and most times they fail. Like any bleeding edge technology generally does not happen. So that creates a serious bottleneck, so to say, even though you are burning money. So option is, what NASA is suddenly doing after the bitch slap of space shuttle is that ask for capabilities, not for design. Like right now ISRO is like, hey, we are designing this small satellite launch vehicle and we have higher partnership collaboration with this, meaning more and more things are being done outside of ISRO. That's useless. What you're supposed to do is like what NASA is doing right now after space shuttle is like, I have this payload, like this volume, as in like this mass, this volume, and this kind of basically constraint, take it from surface level to low Earth orbit, the end. Nothing more than that. Basically how these two things started to happen, Cygnus Craft and SpaceX. There was a very simple contract. This is the tonnage and we need this tonnage taken from sea level to ISS, the end. We do not care how you do it. We do not give a damn how your craft looks. You just give us this capability. We want to do this. How do you do it? That's up to you. You have your design, go YOLO on it. So that is much better. Why it's much better? Because it leads multiple player approach, as in there will be more than one option, and again, two options. Heck, there's supposed to be two options for crewed capsule also, Boeing and SpaceX, but Boeing went lol. But again, that's the whole point. They never got stuck simply because it was not just one option. They had two options. So multiple player gives you better cost option also, meaning if Cygnus costs too much, people will use more Dragon. If Dragon costs too much, Cygnus will be utilized. You see, there is always checks and balances in this design. And this similar approaches is very awesome, meaning this design, that design is completely different, meaning failure in one will not be transferable to other unless they are launched from the same rocket, which generally they are not. That's the awesome advantage you have when you are like, instead of giving me what I want, give me what I need, as in like, hey, I need stuff here, the end. And same is done with commercial lunar project also, where the idea is we want stuff there. We want to colonize moon. So in those sort of scenario, we have to have a lot of technology that we need to test. If we do it ourselves, it would be bonkersly expensive. So the idea is we need a lot of small things to go there. So do that. Take your time. So some companies are like, okay, what if we have a kick stage that dumps it very quickly? What if we have like, orbit raising maneuver that is slower? Again, different countries, different companies, different corporations, they are all coming with different options. We have Astrobotics, we have Firefly, we have Intuition Machines, and another one is also there, I think. Draper supposed to also happen. Firefly Aerospace also supposed. Oh, Blue Origin also supposed to happen. So the idea is, you do what you want to do. I need this thing done, the end. How you do it, that's up to you. I needed a whole drill. You want to use a impact driver, go YOLO on it. If you want to use a hand drill, go YOLO on it. It's up to you. I just want this thing, basically these instruments going to moon. How does that happen? That's up to you. I need this sort of thermal envelope. I need this sort of power envelope, and what weight and mass and all that, go YOLO. So that's a much better approach. That's what NASA is doing now. And I think SLS would be the last rocket where they were like, okay, NASA built this. That NASA logo would be gone. Again, for mission, they will still have NASA because NASA will be the customer. But that's the transition that people are trying to do. NASA should not make stuff. They should always be like, hey, what do you want? You want a telescope? Tell me what sort of surface area you want in your telescope. What sort of instrument rack you want your research. Do you want it to be serviceable? Do you want to be low Earth orbit? What do you want? What do you want? We're going to provide, the end. So that's the future that we are looking at. And the quicker the countries adopt this sort of mindset, the quicker they will progress. Otherwise, they have to eat bitter pills. So this was a presentation on basically how the heck you fund space programs. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst a friend. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show my disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.